Hey guys, welcome to another video. We're moving on, we're getting even more trig identities today. So these are what are referred to as the double angle formulas. Double angle because we're taking the regular angle that was x, and now we're doubling it, right? We're multiplying by 2, so sine of 2x, cosine of 2x, tangent of 2x. So go ahead and copy these into your notes, and while you do that, I'll say a few things. First off, if this is your first video you're watching, stop. Don't watch this video first. Like the videos go in order. So today is the day that officially distance learning started, but I already put videos out the last couple weeks. So start with those, because otherwise these videos, if you start in the middle, they won't make as much sense. Okay, so go back, watch those. There's 5 videos that I've made so far, so just go back, watch those 5, catch yourself up, and then do these. And then also, any assignment that I've posted, again, Aries gives a default due date. There is no due date other than the end of the school year. So any of those assignments that you wish to complete, you can complete those for extra credit. Make sure you are checking your emails. Make sure you're checking Google Classroom. You should be doing it for my class, but probably your other classes as well. Anyhow, that's that. So back to this. This video should be fairly short. This section that we're looking at introduces more identities, but the only identity we're going to cover in this video is just the double angle formulas. And just like with the sum and difference formulas, they only give me the double angle formulas for sine, cosine, and tangent. They didn't give me the double angle formulas for cosecant, secant, and cotangent because it's not really necessary. Okay, if I ever wanted to find cosecant of 2x, I would simply find sine of 2x and then do the reciprocal. If I ever wanted secant of 2x, well, I would just find the cosine of 2x and then just find the reciprocal. Okay, so that's the idea. So we really only need to know these 3. And the nice thing is, with most of these identities, they just kind of build upon themselves. So I'm going to show you where these come from. These are short enough that I have enough room, whereas the sum and difference identities, I linked you guys on the playlist to someone else's video. They had more room to explain and expand on those. But these ones are pretty simple. I have enough room here that I can show you where they come from. So I'm going to erase this. So if you didn't get that, rewind the video, pause it, and get all of this. But anyhow, why is it the case that sine of 2x is equal to 2 sine x cosine x? Well, pretty simple. It's because of the sum formula that we already have. Remember, we should already have this in our notes, so that's why it's important you watch these videos in order. We know that the sine of a plus b is equal to the sine of a times the cosine of b plus the sine of b times the cosine of a. Okay, that's the sum formula. This could be 30 plus 45 or whatever, but we already have this in our notes. Well, if we know this, then we should know this, because the only difference between this and this is that instead of calling these 2 angles here A and B, well, what if those angles were the same? What if these angles were both x? So if I say, well, what is sine of x plus x? Well, sine of x plus x still follows the same format here. So it would literally be sine of x, cosine of x, plus sine of x, cosine of x. Right? If a and b are both occupied by x and x, then this becomes sine of x, that becomes cosine of x, that becomes sine of x, and that becomes cosine of x. And then if you simplify, on the left-hand side, you have sine of x plus x, but that's really just the sine of 2x, right? X plus x is 2x. On the right-hand side, you have a term of sine x cosine x, and you have another term of sine x cosine x. How many of those terms do you have? You have 2 of them. You have one of them here, and you have one of them here. So therefore, I have 2 terms of sine x cosine x. So this is why sine of 2x is just 2 sine x cosine x. So for me, I've mentioned it before, I don't memorize a whole lot of identities because most of them I just know how to get them. So for instance, this is pretty familiar to me that, more or less I haven't memorized. But if I ever thought, wait, what's the double angle formula for sine? I have this one memorized. So if I have this one memorized, not only do I know this, but I also should be able to get this one. Okay, so that's why sine of 2x is what it is. So now let's look at the cosine 2x. cosine of 2x, they actually gave me 3 versions. Okay, so let's see why that's true. They said cosine of 2x is equal to cosine squared x minus sine squared. But they said that's also equal to 2 cosine squared x minus 1. And they said that's also equal to 1 minus 2 sine squared x. So all 3 of those are equal to cosine 2x. So, well, why? Let's figure that out. And just like I just showed you with the sine, I can do the same thing. If I recall, cosine of a plus b is equal to cosine of a, cosine of b, minus sine of a, sine of b. Again, that's just the addition formula that we should already have in our notes. We should already know this. It was from last week's videos. But just like I showed you with the sine, if I replaced a and b with x and x, what I would get is I would get cosine of x plus x. Well, I would just replace a and b with x's. So that would be cosine x minus sine x and sine x. But if I simplify the left-hand side, cosine of x plus x is really just cosine of 2x. And on the right-hand side, cosine x times cosine x, well, anything times itself is squared, so that's cosine squared, minus sine x times sine x, that's sine squared x. So that's why cosine of 2x is equal to cosine squared x minus sine squared x, the first version that they gave me here. Well, why do we have 2 other versions here? Well, one, because this is equal to this, and also this is equal to this, and this is equal to this, and so on. Sometimes it doesn't really matter. Like, if they ask me to replace cosine 2x with an equivalent form, I could rewrite cosine 2x this way, or I could write cosine of 2x this way, or I can write cosine of 2x this way. It really just depends on the situation. Sometimes it doesn't matter. Sometimes, the way I choose to write cosine 2x doesn't make any difference at all. But sometimes it does make a difference. You'll see down the line when we start solving trig equations. When you solve trig equations, sometimes you need to write cosine 2x in a specific way to make the problem easier to solve. But for now, let's just finish this up and see why is it that this is also equal to this and is also equal to this. So this goes back to our basic Pythagorean identities. Remember, we know cosine squared plus sine squared equals 1. And so what I could do, I could keep this as cosine squared x minus, but remember, and we've done enough trig identities now, that sine squared x is the same thing as 1 minus cosine squared x. I can replace sine squared x with 1 minus cosine squared x. Again, this is why it's important you're not just watching this video first. You need to watch the other videos that lead up to this, otherwise you might be like, wait, what? What are you doing? Okay, if you follow all the videos and work along the assignments, this will make a lot more sense. Don't come into the middle of this video series and be like, oh, I'm just going to pick it up here. It's going to be really difficult for you to do that. Okay, let's distribute here. If I distribute here, I get cosine squared x. Negative times a 1 is negative 1. And then a negative times a negative is positive, so that's positive cosine squared x. How many cosine squared x's do I have? I have 2 of them. So I have 2 cosine squared x minus 1. So how is it that cosine squared x minus sine squared is also equal to 2 cosine x, or 2 cosine squared x minus 1? Well, all they did was they replaced sine squared x with 1 minus cosine squared. So that's why this is equal to this. And then let's do the third one. You can probably guess how that one goes as well. So again, we showed that cosine 2x equals this. And then I just showed you that cosine squared x minus sine squared x is really 2 cosine squared x minus 1. And now, alternatively, I can also show you that cosine squared x minus sine squared x equals this. So this time, instead of replacing the sine squared with 1 minus cosine squared, I'll replace the cosine squared with 1 minus sine squared. Okay, so that's the idea here. What can I replace cosine squared with? That's the same thing as 1 minus sine squared x, and then I still have minus sine squared x. And so, well, I have a negative sine squared and another negative sine squared, so I have two of those. So this is 1 minus 2 sine squared x. So the double angle formula for cosine, has three versions depending on what you're doing. Sometimes it matters which one you choose to use. Sometimes it makes no difference whatsoever. Okay, for the stuff we're going to do today and the assignment that I give you today, it's not really going to matter. Okay, but when we're proving identities or we're solving, when we are solving trig equations, it does make a difference which one you choose. Okay, the last one we had tangent 2x. And they told me that tangent 2x was equal to 2 tangent x over 1 minus tangent squared x. So again, I'm just trying to show you why these are true. Now, as I mentioned before, oftentimes I don't bother memorizing tangent formulas. I mean, you can, and that's fine. For me, I don't usually memorize the tangent formulas so long as I know the sine and cosine formulas. Because if I ever want tangent of an angle, I can always just find the sine of the angle and divide it by the cosine of that angle. So I always kind of feel like the tangent stuff, it's a little bit extra. You can do it if you want. You can memorize it if you want, or you can always just rely on, well, I can always use sine and cosine. And you should be good using sine over cosine for the most part. The only time where I would say that you would really need to know this is in the case of like verifying identities or proving identities like we've done in some of the assignments. Okay? So anyways, why does tangent of 2x equal this? Again, just like the other two, it comes back to our understanding of tangent of a plus b. Again, this is already in our notes. This is the sum formula for tangent. Tangent of a plus b is equal to tangent of a plus tangent of b over 1 minus tangent of a times tangent of b. So again, this formula is already in our notes. We should already be familiar with it. And just like I showed you with the sine and cosine, all I'm going to do to go from this to this is simply replace a and b with the same angle, which I'll call x. So the tangent of x plus x is equal to the tangent of x plus the tangent of x over 1 minus tangent of x times tangent of x. So I'm taking the identity we already know, and I'm replacing the a's and the b's with x's. So that became an x, that became an x, that became an x, that became an x. Now all I'm going to do is simplify. On the left-hand side, I get the tangent of 2x, because x plus x is 2x. On the right-hand side, on the top of the fraction, I have tangent x plus another tangent x. So how many tangent x's do I have up there? I have two of them. So that's 2 tangent of x. In the denominator, I have 1 minus, and then I have tangent x times tangent x. Well, that's tangent squared x. And so that's precisely what they give me. Okay, so that's why these functions are what they are. That's why these identities, have this look to them. Why this expression is equal to that expression. So now, those are things you're expected to know. Next year in calculus, for those of you guys taking calculus, not all of the identities come up a whole lot. Like the basic ones come up, the Pythagorean ones do, the reciprocal ones do, knowing that tangent equals sine over cosine and so on. Those ones come up a lot, and the double angle formulas tend to come up a fair amount. Okay, some of the other ones don't come up all as often. We should still be aware of them, but the double angle ones for sure are ones that we actually do see probably more than some of the other ones. Like I would see the double angle formulas more often than I see, say, the sum and difference ones. Okay, so I'm going to look at some problems to practice this. So what we want to find sine of 2x. So find sine of 2x, cosine of 2x, and tangent of 2x. And what they're going to do is they're going to give me some information. Okay, so on the first problem I'm going to do, they give me some information. So these are the instructions for all of the problems we're going to cover today. And then they're going to give you some information. So in this case, sine of x equals 5 over 13. And they tell me that x is in quadrant 1. So what I want to find is I want to find sine of 2x, cosine of 2x, tangent of 2x. And don't you dare, don't say, oh, sine of x equals 5 over 13. The sine of 2x is just twice as big. No, it's not. If that were true, then sine of 30 degrees, which is 1/2, then sine of 60 degrees would have to be 1. But that's not true. Okay? If the angle gets doubled, it doesn't mean you just double whatever that equals. Okay? Otherwise, like I said, that would be what we would have different formulas. What we know is we know that sine of 2x equals sine of x cosine of x times 2. And so in a case like this, I'm just going to use the information they gave me. This is not a unit circle value. Like 5 over 13 is not a value we memorize on the unit circle, right? Our unit circle values are like 0, or 1/2, or 1 over the square root of 2, or the square root of 3 over 2, or 1, or they're negatives. Okay? So the best bet on these problems is to just draw a triangle. Just going to draw a right triangle. We're going to fall back on our very, very basic understanding of trigonometry. Sine of an angle, so my angle is x, I'll call one of my acute angles x, it doesn't matter which one, I'll just put it there. They say that the sine of my angle is 5 over 13. And again, what sides of the triangle does sine form the ratio of? It's the opposite over the hypotenuse. The opposite side is 5, the hypotenuse is 13. So if I was looking for this side right here, I would use Pythagorean theorem. So I know that, let's call this b for now. So I know that 5 squared plus b squared equals 13 squared. So that would be 25 plus b squared equals 169. Subtract 25 on both sides. So b squared equals 144. Remember, b is a side length, so it can't be negative. So the square root of b squared would just be b. That would be 12. So this side is 12. So if you're not familiar with that Pythagorean triple, 5, 12, 13, you can always just do the Pythagorean theorem and figure out the missing side length. Okay, so what the problem is asking me to do, they want me to find the sine of 2x, they want me to find the cosine of 2x and the tangent of 2x. So first things first, let's find the sine of 2x. This angle is not 2x, this angle is x. The angle I'm asking about is 2x. So how am I going to do that? Well, I'm going to apply the formula we just wrote down in our notes. Sine of 2x is equal to 2 sine of x cosine of x. Can I figure out what sine of x and cosine of x are? Well, yeah, I have the triangle and my angle is x. So we're just going to take values from the triangle and substitute them in now. So sine of 2x is going to equal 2 times the sine of x. Well, the sine of x is given as 5 over 13. And then I need the cosine of x. Well, here's x. Cosine matches up the adjacent and the hypotenuse, so it's 12 over 13. And the one thing you have to be careful on is which quadrant am I in? They tell me that x is in quadrant 1 here, so if x is in quadrant 1, then I know all the trig functions are positive, so this is a positive 12 over 13. And now all I need to do is multiply this out. So I'd get 10 times 12, I'd get 120 on top. 13 times 13 is 169. And so sine of 2x is 120 over 169. Okay. So now I need to find cosine of 2x. Because again, the instructions are to find all three of these. So I'm going to find the cosine of 2x. Now remember, we have 3 versions for cosine. On a problem like this, it doesn't matter which version you use. So I'll just use the first version. Cosine of 2x is equal to cosine squared x minus sine squared x. Doesn't matter which form I use, I'll just use this one. So I need cosine squared x. In other words, I need cosine of x, which is 12 over 13. And I need to square it. minus, and then I need sine of x, which was given to me as 5 over 13. And I need that squared as well. So it's cosine squared x minus sine squared x. Then I'm just going to simplify. So if I simplify the first fraction, I get 144 over 169, minus here I get 25 over 169. If I simplify this, 144 minus 25 is 119. So I get 119 over 169. So I found sine of 2x, I found cosine of 2x. Now all that's left to find is tangent of 2x. Now we have a formula for tangent of 2x, and that's fine. You can use the formula for tangent of 2x. Or, for me, what I like to do, since I'm finding tangent of 2x, since I already know these two values, I'm just going to use these values instead of going back to the formula. Okay, you can use the formula if you'd like, but tangent of 2x is equal to the sine of 2x over the cosine of 2x. I'm using that because I already know the sine of 2x and I already know the cosine of 2x. So I can replace sine of 2x with 120 over 169 divided by the cosine of 2x, which is 119 over 169. And now I have a fraction divided by a fraction. Well, if I have a fraction divided by a fraction, I can just multiply by the reciprocal of the divisor. So this is the same thing as 120 over 169 times 169 over 119. The 169's cancel. So tangent of 2x is 120 over 119. So the problem asked me to find sine of 2x, cosine of 2x, tangent of 2x, and so I did. Sine of 2x, cosine of 2x, tangent of 2x. I used the formula for the first two. Tangent of 2x is simply sine of 2x over cosine 2x, and so that's it. Okay, so let's try another problem. Okay, this time they tell me that cosine of x is 4/5. So they tell me that cosine of x is equal to 4/5. And then they tell me that cosecant of x is less than 0. Okay, so I know this. And then cosecant of x is less than 0. Being less than 0 is the same thing as saying that cosecant is negative. And if cosecant is negative, that means sine is negative because they're reciprocals of each other. The reason why they give you this information is they're trying to tell you what quadrant x is in, but they're trying to be a little bit more esoteric about it. And so I know that x is in quadrant something. So let's figure this out. Cosine is positive, so cosine is only positive in quadrants 1 and 4. And if cosecant is negative, then we can't be talking about quadrant 1, so it must be that x is in quadrant 4. Okay, so that's the reason why they give you that information, so you know what quadrant your angle is in. But anyhow, the rest of this problem is just very similar to the last problem. This is not a unit circle value, so I'm simply going to draw a triangle. So I'll draw a triangle again. I'll put x as one of my acute angles. It doesn't matter if you put it here or here, just put it as one of the acute angles. Cosine of an angle is the ratio of the adjacent side over the hypotenuse. So the adjacent side must be 4, the hypotenuse must be 5. And I think at this point in your lives, you probably realize that this side must be 3 then. I had a professor in college. I was taking this advanced geometry class. And on his final exam, he had a triangle that was 3 and 4 and 5. And so I concluded then that, oh, that must be a right angle. And then I based a lot of my answers off the fact that that was a right triangle. And then he marked me wrong on a lot of it. And so I only got like an 80% on the final, which really annoyed me because it brought my grade down to a B+ for the whole class. And he said, well, that's not a right angle. I'm like, yes, it is. I said 3 squared plus 4 squared equals 5 squared, so that has to be a right triangle. And he's like, well, I didn't mean for it to be a right triangle. I'm like, are you kidding me? And so he marked me, he wouldn't like give it to me. I'm like, no. I don't care that you didn't mean for it to be a right triangle. It was, because that's true. If a squared plus b squared equals c squared, the converse of the Pythagorean theorem says that that must be a right triangle. And yeah, so anyways, I'm still bitter, and that was, I don't know, 700 years ago, and I'm still bitter to this day about it. Because I had an A. I had an A in the class, and he brought me to a B+. And for those of you guys who don't know, in college, an A is 4 points on your GPA, and a B+ is only 3.7. So actually, no, 3.3. It's kind of a drag. You know, an A- would be 3.7. He couldn't even give me an A-. He gave me 3.3 grade points. I'm like, are you kidding me? So anyhow, rant over. So I need the same things. Sine of 2x. Sine of 2x, that's equal to 2 sine of x cosine of x. So again, I'll just find those values that I need from the triangle. So I have 2. And then I need sine of x from the triangle. Sine of x matches up the opposite over the hypotenuse. So that's 3 over 5. But you got to be careful here. X is in quadrant 4. So when I'm finding sine of x, well, in quadrant 4, sine is negative. So don't forget your negative sign here. And then cosine of x, I can either look at my triangle, or I can understand that they gave me cosine of x is 4 over 5. So now if I simplify this, I get 2 times negative 3, I get negative 6 times 4 is negative 24. So I have negative 24 over 25. So that's what sine of 2x equals. So now I'll find cosine of 2x. And again, cosine of 2x, I have 3 versions. On problems like this, it doesn't matter which version I use. So since it doesn't matter which version I use, I usually just use the first one, which is cosine squared x minus sine squared x. So cosine squared x, well, cosine is 4/5, so that would be 4 over 5 squared, minus, and then I need sine squared x. Sine, we already said before, was negative 3/5. And then I square that. So if I work this out, I get 16 over 25 minus 9 over 25. So I get 7 over 25. So we found the sine of 2x, we found the cosine of 2x, and now I just want the tangent of 2x. Now again, I could just jump back and use the formula, or since I already know sine of 2x and cosine of 2x, I can simply write the tangent of 2x is equal to the sine of 2x over the cosine of 2x, and just substitute these values in. Sine of 2x is negative 24 over 25. And cosine of 2x is 7 over 25. And now I have a fraction divided by a fraction. And so I get negative 24 over 25 times 25 over 7. The 25's cancel. I get negative 24 over 7. So then we found sine of 2x, cosine of 2x, tangent of 2x. So that's the idea. Hope everyone has this. Okay, I'm going to do one more and then I think we'll call it a video. So this time they give me that tangent x equals negative 1/3. And they tell me that cosine of x is greater than 0. Okay. So again, this is given information I'll use to find sine of 2x, cosine of 2x, tangent 2x. But the other part here, whatever they give you there, if they don't explicitly tell you what quadrant x is in, this is basically a hint at that. So tangent is negative, so tangent's negative in quadrants 2 and 4, and they tell me that cosine is positive. Well, cosine is only positive in quadrants 1 and 4, so I need to interpret this as being x is in quadrant 4. The only quadrant on the graph where cosine is positive and tangent is negative is quadrant 4. So I can conclude that x is in quadrant 4. And again, this is not a unit circle value, so I will make a triangle. And even if it was a unit circle value, you can always make a triangle. On my triangle, do not put the negative on the triangle. Don't try to figure out, should I call the 1 negative or the 3 negative, whatever. The triangle should just be made up of positive numbers. You'll get in the negatives where they need to be based on what quadrant we're dealing with. Okay, so for us, remember what tangent matches up. It's opposite over adjacent, so opposite over adjacent. So I want the hypotenuse because I need all 3 sides of the triangle in order to find everything I need to find. So we use Pythagorean theorem. So I'll just do this off to the side here. So I know that 3 squared plus 1 squared equals c squared. So that's 9 plus 1 equals c squared. Take the square root on both sides. Again, c is a length, so it can't be negative. So the square root of c squared is c. And the square root of 9 plus 1 is the square root of 10. And that doesn't simplify. So this is square root of 10. So, just like the other problems, I need to find sine of 2x. And that's equal to 2 sine of x cosine of x. So I will replace the sine of x with what it equals. Remember, sine matches up the opposite over the hypotenuse. That's 1 over the square root of 10. But again, keep in mind what quadrant we're in. We're in quadrant 4. Sine is negative in quadrant 4. And then I need the cosine of x. The cosine of x is adjacent over hypotenuse, so it's 3 over the square root of 10. I'm in quadrant 4. In quadrant 4, cosine is positive, so that one's positive. So let's simplify this. I have 2 times negative 1, so it's negative 2 times 3, so I get negative 6 over. The square root of 10 times the square root of 10 is just 10. So negative 6 over 10 reduces to negative 3 over 5. Okay, so let's find cosine of 2x. Cosine of 2x, I can write that as cosine squared x minus sine squared x. Again, it doesn't matter which version you use, I'm just choosing to use this version. So cosine squared x, well, what's cosine x? It's 3 over the square root of 10 squared minus, what's sine squared? It's 1 over the square root of 10. Quadrant 4 means it's negative, but that's being squared anyway, so ultimately that doesn't matter. So when I square this one, I get 9 over 10 minus when I square this one, I get 1 over 10. So 9 over 10 minus 1 over 10 is 8 over 10. And 8 over 10 reduces to 4/5. So I know the sine of 2x, I know the cosine of 2x. Now I need the tangent of 2x. And again, I can just write the tangent of 2x as the sine of 2x over the cosine of 2x, because I already know those values. The sine of 2x is negative 3/5. The cosine is 4/5. I have a fraction divided by a fraction, so this is the same thing as negative 3/5 times the reciprocal of the divisor, which is 5/4. The 5's cancel, and so tangent of 2x is negative 3/4. So that's it, and that's all I'm going to assign for today's video is just stuff like this. It'll be a short assignment. Again, don't do these out of order as much as you can. Watch the videos in order. Do the assignments in order, because if you try to just pop in the middle, you're probably going to get lost, and then I'm going to get emails from you like, what do I do? And, you know, I'll help you, but at the same time, it would have been easier had you been following along the whole time. So whether you've been keeping up the whole time, or you are just starting today, April 13th. Either way, just go back to the beginning. There's not that many videos prior to today. Watch those, catch yourself up. Again, there's no due dates on anything really other than the end of school. Okay, thank you for watching. See you guys later.